Hi, my name is Amirul Amri bin Abu Mansor. My matrix number is 065090. I will discuss about the packet that each team members capture by using Wireshark application. Since we need to count the number of each protocol that appear in each member capture result, so I will discuss about the packet that we able to capture from the result. UDP or User Datagram Protocol is used for establish low latency and loss tolerating communication between applications on the internet and speeds up transmission by enabling the transfer of data before an agreement is provided by the receiving party. Does not provide data sequencing, also does not retransmit lost packet. So UDP will beneficial in time-sensitive communications such as VoIP, DNS lookup, and video audio playback. TCP or Transmission Control Protocol, used for enabling applications and devices to send packets across the internet and ensure the successful delivery of data and messages over network, and provide data sequencing and retransmit the lost packet. Example like peer-to-peer sharing such as FTP and SSH, send and receive email, IMAP, POP, SMTP, and web access HTTP. The next protocol is bad TCP. Bad TCP will happen when the buffers are full, the host cannot longer accept new session requests and begins dropping the new session request, effectively causing a denial of service. But it is common for packet sniffing tools since we enable the checksum offloading on our wireless card. The next protocol is HTTP, Hypertext Transfer Protocol, used for access the data on the World Wide Web. Transfer the data in the form of plain text, hypertext, audio, video, and so on. The next protocol will be SMB, Server Message Block, protocol that uses a client-server model to share access to files, resources, and communication between systems attached to network. Allows the connected system to remotely open, edit, share, or print files across the network. Next is ICMP, Internet Control Message Protocol, used by network device to diagnose network communication issue, mainly to determine whether or not data is reaching its intended destination in a timely manner. Crucial for error reporting and testing. Last but not least is ARP or Address Resolution Protocol. ARP is used to find the MAC address of a device based on the IP address. Since all hosts on a network are located by their IP address, but network interface controller do not have IP address and they have only MAC address. So ARP is needed when a device wants to communicate with another device on a local area network or Ethernet. Thank you, and we will move on to the next slide.
The color of packet that have been displayed in the packet list pane is a tool that spots and highlights the packet of interest. There are two kinds of color rules in Wireshark, which are temporary rules that only valid until you run the program, and permanent rules that are safe during the run of the Wireshark and available when you run it again. To create temporary rules by selecting packets, pressing Ctrl key and the numbering key. By doing this, you will create a coloring rules in the current selected packet. It will try to create a filter based on the list that consists of TCP on top and the list of UTP followed by IP and lastly Internet. Temporary filter can be created by selecting colorize with filter by color, then right-clicking the packet data pane. If you want to permanently colorize the packet by selecting View, next click Colorize Rule. Wireshark will display the coloring rules page. Dark yellow is TCP, dark blue is DNS traffic, light blue is UDP, meanwhile the black is TCP packets that have problems. Coloring packet do not create names rules on the page. Those rules are temporary, so when you close the capture page, you will use the default colorization. If you want to save the coloring rules, just do it by right clicking on the packet and click on the colorize rules. To select specific rules, you can choose new color rules, and this will allow the color rules that you have created permanently rules. Even when you close the Wireshark, the rules will still present. That's all for me.
Hello, my name is Anas bin Danial. Before we start to capture packet using Wireshark, we record our type of internet connection, ping, download speed and upload speed using speed test website. First, Amirul, who used a Wi-Fi connection for this testing, he got 220 plus for download speed, 248 for upload speed, and 40 milliseconds for ping. Next is FARIZ, who use a catering hotspot connection for this testing. He only got 40 Mbps for download speed, 7 Mbps for upload speed, and 40 milliseconds for ping. Amri recorded his download and upload speed, which is only 3 Mbps and 2.5 Mbps respectively. The ping for his testing is 72 milliseconds, which he using tethering hotspot. For the next slide, Anas, which is me, use Wi-Fi connection with 28 Mbps for download speed and 68 Mbps for upload speed. The ping I got for this testing is 23 milliseconds. Furthermore, Barr, who also test using Wi-Fi connection with a ping 48 milliseconds. The download speed Barr recorded is 11.9 Mbps and upload speed is 3.41 Mbps. Lastly, Syakirul, who use wire connection, got the most high download speed on this group, which is 300 Mbps. The upload speed for wire connection is only 52 Mbps with a 30 millisecond ping. So for the next slide, we got graph for internet speed. The first bar represent upload speed in Mbps. The middle one represent download speed in Mbps, and the last bar represent ping in millisecond.
Hello, my name is Abdul Kadir. In this message, I will give you a brief overview of the whole packet graph and explain why different members of the groups are sending and receiving different types of packets. Firstly, a packet on the internet is a unit of data that is routed from its source to its destinations. This approach of network packet transmissions ensures the data reliability by removing the requirement to transport data as a single large file. The reason is that while using a Wireshark to capture the packet, each member was running a different numbers of applications. For instance, Amri was torrenting a large game file. Anas was downloading multiple videos from Netflix. Aiman was downloading and playing a game simultaneously, and Amir was watching multiple YouTube videos, and I was only using one application. This explains the vastly different numbers and types of protocols that were recorded in each Wireshark and displayed in the graph. Of course, there are more elements such as the various connections and varying internet speeds at the time of the capture. This undoubtedly had an impact on the quantity of packets that each group members transmitted and received. In other words, the user will send and receive more data packets if the internet speeds and the capacity are higher. That's all from me. Thank you.
Assalamualaikum, my name is FARIZ HELMI bin TALIP and I'll be presenting the graph for TCP related packet. As you can see, Anas has the most TCP packet, which consists of over 6 million TCP packets. Among those packets, he has 575,485 bad TCP packet and 303 TCP reset packet. Next to have the most TCP packet is Amri with over 4 million TCP packet. Among those packets, he has 549,592 bad TCP and 1,148 TCP reset packet. Amirul has 3,020. Amirul has 3,2700. Kena one goal apa ni? Oh, okay. Amirul has 327,420 TCP. Amirul has 327,420 TCP packet, 117,702 bad TCP packet, and 291 TCP reset packet. Syakirul Aiman has 180,000 packet, Syakirul Aiman has 180,067 TCP packet, 8,941,000 bad TCP, and 274 TCP reset packets. Myself, FARIZ, has 147,454 TCP packets, 43,720 bad TCP packet, and 92 TCP reset packet. And finally, Abdul Barr has 19,344 TCP packet, 14,707 bad TCP packet, and 225 TCP reset packet. Thank you.
So, packet is a fundamental data item that is compiled and sent through a computer network, typically a packet switch network such as the internet. Each packet or block of data is a component of the entire message and contains necessary addresses, information to help identify the sender, computer, and message intended recipient. So, the reason why every member got different type of packet is there were various number and kind of application running for each member. As for me, I mainly using streaming platform such as YouTube and various websites for streaming and watching movies, while other members was using a lot of other application which such as Gmail, Facebook, gaming and many more. Hence, explain the significant difference for amount and type of protocol capture in Wireshark. As shown in the graph before, everyone in the group use a different kind and speed of internet connection is another factor of why each member have different packet, because of we might encounter a little hard time running certain application considering their unstable internet connection that obviously affected the number of packet sent and received by each other member. In other words, the higher the internet capacity and speed, the bigger the volume of packets sent and received by the user. That's all from me. Thank you.